Okay, so first things first, eye protection. Anytime you're working with any kind of laser, obviously it's a danger to your eyes and your skin and small animals, anything. So these are not regular glasses. There's two pairs of these glasses in the back. It's not just that you're using safety goggles. These are actually, the lenses are tuned or whatever you want to call it. I'm not like an optical engineer or anything like that, so I'm probably going to totally BS my way through the laser stuff. But essentially, the wavelength that the laser works on, these are meant to block that particular spectrum. So it's not just that it's glasses.
Same as that shield is made?
Yes, exactly. There's a shield on top laser cutter. That also, in general, will block the laser, but it doesn't mean you don't need to wear the glasses, because anything could happen, obviously. Also, even if you're wearing the glasses, just the brightness from the cuts, especially vector cuts, is enough to do some damage if you stare at it for too long, kind of like the sun. So I would not recommend staring at the actual brightness of the laser as it's getting output. So always wear eye protection. First rule. Again, we're going to talk about how the laser works. What can it do? I'll show some examples of pieces I've worked on, and then if anyone has any questions about what other kind of things you could do, feel free to ask. I'll try to show you as many of the tricks that I've learned as possible to get decent results from it without wasting a lot of time. Then we're going to talk about the software you use for the laser. After the safety stuff, really most of the stuff you learn using the laser is based on preparing the file correctly to get the results that you want on the material you want. So a lot of this is going to be focused on the software side of things. And then we're going to talk about basic maintenance and troubleshooting. And then we'll kind of open it up for hands-on and questions for as much time as we can. So the laser cutter in general, just like all these machines, is a computer-controlled thing that does something, and this is a burns thing. So, that's essentially a computer-controlled hot glue gun. The CNC is a computer-controlled drill press. That is a computer-controlled burning device. So essentially it outputs a laser that is a very high temperature, and it burns things. So because it burns things, you have to be very careful about what you're doing with burning. So essentially it's an optical device, so it works on the concept of focus. So just like a camera or glasses or anything like that, for the beam to work, it has to be in focus. And there's a number of mirrors and lenses inside the device that I'll show you when we go back there. But essentially, we've got a work area that's, in that machine, it's 20 inches by 12 inches. So that's the maximum work surface without taking the bottom off the thing, which I'll talk about at the end. That's for advanced. So 20 inches by 12 inches, and it has an X and a Y movement. So if you look at the laser tube in the back, the laser shoots out the laser tube. There's a mirror here that then goes to this arm, and then that mirror bounces off to this arm. So in general, the laser will perform, like let's say the laser's not aligned or something. It would work pretty well up in here, but over here you'll start to see performance degradation. And the reason for that is the laser's traveling a longer distance, and the lack of focus is more prevalent at that longer distance. Just like if you had a telescope or something, small changes in focus matter a lot more, the further you're looking. So essentially, when we talk about cleaning the mirrors, aligning the mirrors, I'm talking about these three mirrors. And then also, this moves around at a set speed, and this works at a specific power. So any job you do, whether it's raster or vector, we'll talk about that in a minute, you set those two values, speed and power. So obviously, if the laser is set up to go, if the head is set to move very slowly and the power is very high, it's going to really burn the crap out of stuff, as opposed to it moving very quickly but using very little power. It's more likely just to etch things. So you want to work with those two levels, speed and power, to get the results that you want. For focusing, in general, it has to be in focus, but the main thing you need to know is there's a spacer back there that you align. You put your material in the laser, you put the spacer on, and then you adjust the head so it is sitting on the spacer. So when we go back there, I'll show you how to do that. But essentially, depending on the lens type, this is a 2.0 lens that's on there now. You also have a 2.5 lens. The 2.0 lens is a pretty decent lens for general purpose. The 2.5 lens has a longer focal length. So if you're doing things that require deeper cuts, that's the only time you need to change the laser lens. But for most purposes, and I'd say until you're using it a lot more and more advanced you should not be changing the lens out unless you really know what you're doing. So we've got a spacer there that's wrapped in green tape. That's for the 2.0, and that's what you use to focus the laser above your material. What that also means is that if you have a material that is not flat or even on the top, it's not going to cut evenly across the surface. So generally, you're going to only want to be lasering on surfaces that are level across the entire spectrum of that surface.
Is the depth something that can be changed, or is that dependent on which lens you're using?
The depth, it depends on the lens, and it can be changed, but why would you want it? Why would you need to change it?
Well, for more detail or a deeper cut, like you were saying.
Yeah, so essentially the only time I think you need to kind of like stop in the, so if you're using thick wood, you probably want to use the 2.5 lens because it's going to have a larger focal area. Right. So the 2.0, like, it's within about 1/4 of an inch, it's going to be pretty accurate. So like if you're doing engraving and stuff or cutting, after it gets past that 1/4 inch, it loses a lot. Okay. You could then stop the job and drop it down a tiny bit to then finish the cut, or you can change the lens. Okay. But in general, you're not going to want to, in general, you're not going to have a lot of luck doing anything that's more than about 1/4 inch depth. Yeah, anything past that, you're probably pushing it anyways. So, the laser can basically cut anything that won't kill you or damage the laser itself. And we'll talk about the materials that will kill you and won't kill you. But essentially, people have done everything from chocolate to metal, to leather, to paper, to, you know, there's a lot of different options. And I'll try to show and talk about a lot of examples. If you have a particular project you were thinking about using, let me know. But you can do everything from, like, let's say you're building a birdhouse and you wanted to not cut the wood. You could lay out the plans, have the laser cut the pieces, then to put back together again. And then you can do more things like engraving or rastering for photos or for portraits. So depending on your use, you want to change the settings on it. But in general, it does cutting and engraving. So some combination of those two things is what the laser is appropriate for. It is not appropriate for, let's say you had a piece of wood and you wanted to drill a hole in the piece of wood. You could use a laser for that, but you probably want to use a drill press for that. And I say that because I was just in Denver and I visited the Hackerspace there, and they had a giant, awesome $50,000 laser cutter. It wasn't working, so I asked them why it wasn't working, and because there was a fire. And someone left the laser unattended, which is major no-no. It can cause a fire. So like this, if you left it unattended, worst case, you come back and it's a bunch of spaghetti plastic, but it's not going to start a fire. Like, that will start a fire. So what the person in Denver was doing was literally trying to create a hole in a piece of thick wood. So the laser was sitting there in one spot just burning, right? So, of course, you start a fire at that point. So you want to think about what is laser appropriate for, what's it not appropriate for. Is there another tool that might do this job better than the laser cutter, right? So it's mainly for cutting precise cuts on thin wood and for engraving. If you wanted to just cut a piece of wood in half, you know, use a bandsaw, use a table saw. Like, there's a lot of stuff back there that's going to do a lot of things better than laser cutter. But if you need precision or accuracy or actual dimension or quality of image, is what it's good for. There's a couple examples here of more metal type things. It can cut metal, but what you need is a marking spray. So if you have any projects where you want to do aluminum or steel or anything, it will work on those, but without a marking spray, you won't see the result. Essentially what it does is, it's like a $50, you get it's like a can of spray paint essentially, and you spray the area that you want to show up in black of the metal, and then anywhere where the laser hits that marking spray, it will turn the metal black. There were another member, Ida, did some really beautiful portraits on pre-bought metal pieces. There's a site called laserbits.com, and that's a good place to buy. If you want to just see different material types or different things you could do laser, I would check out laserbits.com. For example, you could do like stamps. So say you have a rubber stamp. You could buy blank rubber stamp templates that are just flat, and then you could prop it up in the laser cutter and do an engraving, and then of course, and then you've got a rubber stamp design. So LaserBits is a really good place to browse around to see, you know, what types of starter projects you could do. So that's a good, and they have the pre-treated aluminum sheets and bronze and copper and different metals with the pre-spray on. But if you put a metal in there, it's not going to show up unless you have that marking spray. I'm going to mention two things, raster and vector, and that's two methods that the laser cutter uses to work. So vector cutting is essentially where it's cutting. It's more cutting or engraving specific lines. So everything we want to work with is a vector file, but you can use raster mode with a vector file. And essentially the difference is if you wanted to do a portrait or you wanted to do some kind of photo type image. So like this, I'll pass it around real quick. This is a map, and this is using a 3D engraving method. This is all raster. So raster, the head of the laser just moves every line like a dot matrix printer or something, and it either is on or off. So essentially what you get is a filled-in type image. And then there's a way to do 3D engraving where it does multiple passes over the same image, which is what that map was done with. So the areas that got hit more than once are deeper, and then areas that didn't get hit are higher up. So essentially, if you're looking for an image on something, and it's not just line-based, you want to go with raster. Okay? And then vector is sharper lines. It generally is a lot faster than raster, because raster is just going to go over every inch of it, whether or not it's going to hit that spot. So just to give you an idea, like each pass on that with raster with 250 DPI was about a half hour. And that was 8 passes, so that was 4 hours for that small piece. A vector, and then if you flip it over, the vector image on the back, that was about 15 minutes. So, but it's also much less dense, that sort of thing. So vector is also used for cutting. So if you want to do a cut, you would do a slow, strong vector. So maybe, like to cut through that wood, you'd want to use about 10 speed, 100 power, and whatever line it goes over is going to cut straight through. If you wanted to just do an etching with the vector mode, which is also good if you want more of a line type drawing like the back of that, you would do more like 100 speed and 5 to 10 power. So you essentially change those power settings and speed to do the cutting versus engraving.
Can you change the power and speed
Yep.
in the course of a run, or is it let it run once, you change it?
Yep, you can. So the way it works is that when you prepare your vector file, so vector files are, so let's say you have like a PNG or a bitmap or a JPEG or something. It's a set resolution, and if you were to zoom in on it, you would get pixelated because the information about the image is about that resolution. A vector file is a description of lines. So whether you zoom in or zoom out or expand it as big as you want, it can handle it because instead of saying these pixels are these colors, it says draw a line between this point and this point. So if you expand it, it just does it again and the line's clean. So we always prepare all our files in vector files. And in the vector file, if you set different layers or lines to different colors, it's going to show up as a different layer in the full spectrum software. So let's say I wanted to do a job that was an etching, but then I also wanted to cut around the border. What I would do is make the border one color, like red, and then make the etching maybe blue or black or something. And then when you open it up, you'll see it broken out, and you'll see red and speed and power, blue, speed and power. So what it would, and then order as well. You can set the order in which it goes through those colors. So essentially, you could have more dimension. You could do like the 3D engraving thing, where each pass is a different speed. But basically, like with raster, it's one speed for the whole pass, and then vector, it would go like if you had 10 colors and each one was a different power, it would do the first color all the way through, change power. So it's one power setting as it's going, but within a single job you can have multiple passes. So this is the important stuff. Never, ever, ever use these materials. And this is no joke. Like PVC creates chlorine gas, like literally chlorine gas. It will kill you. Like it will kill everyone in here. We have the thing vented, and we're going to talk about checking to make sure the venting is working. But it doesn't matter. Like, and literally ABS is cyanide gas. Like you could not think of two worse gases to output from something, right? Like, so any kind of plastic in general, forget it. It's not, you don't want to use the laser cutter on any type of plastic. If you are unsure about what your material is made of, or if that material is approved, you do not cut it, okay? Does that make sense? Like, if you think like, oh, I'm pretty sure this is this, but it's got some kind of laminate on it or something, figure it out first. So, one trick that Hardik taught me that's not foolproof, but it will give you some idea of what you're working with. So let's say like PVC. This is a PVC pipe. Obviously, it's on the list. But so you had an object and you weren't sure what it was, or it was a wood and it had some kind of weird plasticky cover on it. You can take a piece of copper wiring and a torch and heat the copper wiring up very hot and then touch the copper wire to the material you're thinking of cutting on. And what that does is the material is going to melt a little bit and it's going to get a little bit on the wire, right? So then the wire has a little bit of the residue of the material on it. Hit that again with the torch and look at the color of the flame. If the color of the flame is anything outside of red, if it's green or if it's really blue or purple or anything like that, forget it, okay? Because green means dead, okay? So
red is everything.
red is regular fire, right? I mean, like, yeah. So if it looks like a normal flame, if it's not green, I mean, you'll see green. It'll be little sparks of green, or if it's sparking, those kind of things, that means it's a no-go material. So you're welcome to try that. You all have signed waivers. If you wanted to just take a copper wire and a piece of PVC and go outside and just see for yourself, like, oh yeah, that's a green flame. Like, but again, it's not a guarantee. Okay, so that's just kind of a tip that it'll help. But if you're still unsure, just don't do it.
That's for finding out what not to do.
Yes, exactly, right. Green, don't do it. Green does not mean go in this case. And then, aside from this, I would say very thick materials, anything resinous or wet or anything, don't do. Anything that if you think about the particles, because also it's not about safety, but also maintenance. So any kind of particulate that's going to get generated in the machine that's going to stick to things. Like resin, we did a resinous cut one time and it was just like goo on everything, and it's not going to hurt anybody, but it's going to be more likely to start a fire or to damage the equipment or clog the equipment.
So what about things like carbon fiber coils set in resin and stuff like that?
So carbon fiber is, I believe, okay. It's not on this list, but I don't. No. Carbon fiber is not going to cut. I don't believe, but. Carbon fiber with something else on it, you might be able to etch or something. So woods are fine. All woods are fine, including MDF. I would just worry about laminates or finishes. It's probably okay with most finishes and stuff, but you should always test a small piece, and you should always be in front of the machine to see if it catches or lights or anything like that, okay? Even if something's painted on or something, it's probably fine as well. But again, test a small piece. If you're not sure what it's made of, don't do it. Paper's really good and cool. We had a member that actually just left, but he did a really cool project where he essentially took thick paper and then did an origami project to where he did a very, very low power, and he scored the paper. So in origami, a lot of times you do a lot of pre-folds, right? Like you see origami plans and they just look crazy, and you do all the pre-folding, you lay it flat, and then you build it again. So what he did is he took these origami plans, and then instead of doing the pre-folds, he basically scored the paper with the laser. So then once you take it out, it just folds right on that score. So, it's not just cutting paper, but also even scoring it or marking on it. If you had a thick enough paper and you did a low enough power, you could, you'll see a little singe on it. I've done clothing and stuff too. Like at very, very low power, it just singes the clothing. So you get creative as long as you're not going to kill anybody or damage the machine. So cardboard's fine, cork is fine. What do you call the project board used for science fairs? Like Elmer's, like the foam board? Don't use foam board. Foam board has plastic in it, but cardboard is fine. And then acrylic is great. If you're looking for a plasticky material, use acrylic. So it comes in.
Styrofoam is out.
Styrofoam's way out. Way out. Definitely don't use styrofoam. But yeah, acrylic, lucite, plexiglass. If you're looking for a colored plastic, you can get acrylic in all kinds of colors, thicknesses, finishes. That's what you want to go for that. And then cloth, like I mentioned, leather is awesome and great. Like felt, all those things can work really well. You just want to test out the piece of material to find your right power setting.
So how is it that the paper doesn't just go through?
Because you can set the power very, very low. Yeah, and it's thick paper.
0.1?
What was that?
Can you set it lower than
You can set it lower than 1. You can do 0.01, 0.1. Yeah. Which is what I had to, I ruined a lot of shirts trying to do the t-shirt thing.
Yeah.
And then finally, it was like 0.001 or something crazy that just singed it. So, yeah, just a very, very low power, very fast speeds.
You can cook stuff in paper if you're careful.
Yeah. And you also want to, if you're using anything like paper, you want to probably weigh down the corners because there's a lot of airflow going through the laser cutter. And anything light like that could, get lifted and moved and things like that. So also, I would not stack materials because that's going to be a larger. Like, let's say you wanted to cut 4 pieces of plywood at the same time. Don't do that because A, you're going to lose focus as you go through the higher layers, and B, anything that's stacked, it's going to generate a lot of heat, and it's going to be a lot more chance of fire happening because of the material being stacked. Cool? No one's going to kill themselves? Good.
No promises.
Yeah, I mean, you signed a waiver. So,
Speaking of phone, though, do you guys have a hot wire cutter?
I don't know if we don't have a hot wire cutter, no. But if someone wants to donate one, we'd gladly take it. So last thing is anodized aluminum. Again, you want to probably use the marking spray to get any kind of real results on it. There's a lot of laser cut MacBooks and stuff out there. It's definitely doable, but you want to be very careful because you don't want to fry your MacBook, right? So,
Unless you want one of the new ones.
yeah, exactly. So again, painted coated materials are fine. It just kind of vaporizes the paint. But again, just err on the side of caution. If it's a ton of paint, if it's really old paint, it's got lead in it or something, like, probably don't do it. If it's smoking a lot, if it smells funny, just stop the job. And then any kind of stone is going to work. It's going to basically like powder it, but you're not going to cut through stone. If you wanted to cut through stone, you need to use like a water jet cutter or something we don't have.
Now, for the metals you mentioned about how it would burn or change the color on the surface, but it really cut through it?
No, it's not going to cut any kind of metal, no matter what the thickness is. Oh yeah, glass and mirrors work really well. So let's say you wanted to put a pattern in a mirror. You could do the back side of the mirror because you don't want to reflect the laser back on itself, right? So don't use a mirrored surface laying as a mirror. You want to flip it over, and that mirror is a coating on the back. It's just a piece of glass with a coating on the back. So then whatever gets etched away is going to be see-through, and then whatever doesn't get etched away is going to be mirrored. So you could take a mirror and make a nice design on it, a pattern around it, and then glass is going to etch but not cut. So it's going to be basically like a faint line in the glass, which can look really nice depending on the look you're going for. It just all depends on, but you're not going to cut glass with this thing. Any questions on materials? Okay. We have 2 lasers. That's a 45 watt full spectrum laser that came like that. That's a Chinese eBay laser that you can get for $600. And then we are upgrading it to make it worth probably more like a $2,500, $3,000 type of laser cutter. So when that one's working again, it's going to be better than that one. It's just a little bit smaller build volume. So once that's working, if you're trying to decide between the two, that's 45. That's 40 as well. So it's around the same. Fairly low power as far as laser cutters go, but I've never said like, oh, I wish I had a stronger laser tube. Like mostly it's like I want bigger, maybe a little faster or something, but it cuts through what it needs to cut through. Most of the time, if you need to cut through something that the 45 watts not going to cut through, you shouldn't be using a laser cutter in the first place. You know what I mean? You should just be using a tool that cuts that thing. So before you use a laser cutter, you want to go through kind of a pre-fight checklist. So how many people are actually listening right now? You could probably all fit back in the room. I'll go through the rest of the thing and then we'll actually do all this stuff. So I'll go through this quickly. So essentially, the laser cutter to be cooled, it uses water cooling and air cooling for 2 different things. So the water cooling actually runs through the laser tube itself, and then there's 2 types of air cooling. There's the general vent fan that's pulling up all the gases, and there's also an air compressor that blows air out of right next to the laser head itself. So the venting is to get the fumes away, and then the air compressor is to keep debris off of the stuff you're cutting. So as it's generating dust, it's blowing it off of the thing. It's also keeping the surface temperature of the material cutting low. Okay, so essentially once you turn it on, you want to make sure that the airflow is working, that you can feel air moving through it, you can feel air coming out beneath the laser, not while it's running, and that you can feel water running through the tubes. Does that make sense? So if, for example, you started it, but for whatever reason the water pump was not turned on, you could start a job and everything seems fine, and then an hour later the laser tube is burned out completely and we have to buy a brand new laser tube. So it will kill it quickly. And even if it doesn't kill it in that job, you took hundreds of hours off of the life of it probably. So it's very important to validate that, and you can see it filling up with bubbles as long as it's clean enough. If you can't see the bubbles filling it, it means it needs to be clean, so go ahead and clean it at that point. So I'll show you once we go back there and turn it off and on, I'll show you how to check the tubes and stuff. So Those are important things. Uh, always make sure the extinguisher's nearby. The glasses are around. If you don't have the glasses, you can't find them. Don't use the cutter. If you can't find the fire extinguisher, don't use the cutter.
Is the do not cut list posted yet here?
It is. It's on. There's a list of rules. It's on that list. There is an emergency stop button, a red button on it. Use that if you ever have to. And again, if in doubt, don't do it. Just find someone that knows slightly more. Like, I haven't been using it that long. I just know a little bit more than you guys right now. So find someone like me that's used a little more, has broken it before, and to help you not break it this time. Again, the laser tube is the most expensive piece of it, so it needs to be kept clean and cool. Never open the top of it. Not obviously. Nothing is obvious. Don't open the top of the thing while it's running. Even with glasses on. It will keep running. It's not. I mean, I think it has a little switch or something, but I've seen it open before. While it doesn't stop right away. So don't open the top of it. And again, top is the right kind of. It's the same material as this, but doesn't mean you don't need to wear glasses still. Okay. And that goes double if you ever are working with the bottom off, which you should not do unless you got permission. You're working with someone that's done it before. Myself or Jeff are pretty much the only people that have done that. So, but if the bottom's off, obviously that layer's not there. So if you sat there and looked underneath of it, you could really easily burn your eyes pretty quick. And again, do not go away from the laser while it's running. I was going to say you don't have to sit right on top of it. Sit right on top of it, especially for the first few times. Definitely don't leave. Don't come back and put headphones on for 2 hours while it's running. Just bring your laptop in there while it's running. Because again, a lot of things can happen. There's a hose, the air compressor hose, can get caught underneath the laser and get cut, which has happened 2 times in the last 2 months. So you want to be watching it to make sure it doesn't happen. It can catch and move what you're working on, and then your job gets all screwed up. Just make sure you're around it. If there is a fire, if you see a flare up, just watch it. Sometimes most of the time they'll go away. If it doesn't, you need to hit the red button, use a fire extinguisher if it's still on fire, and call 911 if it's still on fire. Does that make sense? Generally, like stop, drop, and roll if you're on fire. But the red button's the most important thing. Stop it from getting worse. And then give it a second to extinguish itself, but if it's spreading or if it's bad, use the fire extinguisher. I would rather have to clean up, the fire extinguisher and because it was like a little bit of a flare-up and you were a little bit worried about it, than not. So err on the side of using the fire extinguisher. Yeah, and again, like your lives are worth more than the tool. Just get the fire out. We'll deal with it after that. If you want to use a project, this slide's kind of unnecessary. I'll delete that. Just you want to pick something to cut, and you need a file that describes how it's going to be cut. So again, the build volume on the inside is 20 by 12. Even if you're using a thick material you don't want to cut, if it's too thick, you're not even going to be able to focus the laser correctly. So in general, most things you're going to cut are between 1/8 of an inch to 1 inch, maybe a little bit more, and then 20 by 12. And then Inkscape is what is the best free software for designing the files and preparing files for use. You can also use Illustrator. Illustrator is a little bit more powerful, but honestly, Inkscape is really solid. If you do use Illustrator, one thing to note is that you need to increase the size of the file by 25%. So scale at 125% before exporting. And the reason is because the default DPI setting of Inkscape is different than it is in Illustrator. Okay, so you can use Illustrator, but if you export the file and then you open it up on that computer in Inkscape and then send it to the printer, it's going to come out too small. So just upsize it by 25% if you're using Illustrator. If you're using Inkscape, forget all that. Inkscape's fine.
Even if it's a vector image?
Yes.
So if
You still set the dimensions.
Oh, if using Illustrator, we can set the DPI though.
Doesn't work.
It doesn't work.
Don't know why.
Okay.
Because basically, like you can set a custom I mean, maybe I'm not an Illustrator expert, but I've found all the places I could find to set the DPI.
Yeah.
It still does the same thing. It's something about the way the SVG file format is embedded or the version they use or whatever. I don't know.
What do you export that?
SVG is the best. PDF actually works as well. I think SVG is the most reliable, though.
And that's the native format for Inkscape.
Yes, Inkscape and Illustrator are both vector-based programs. They're meant for doing vector logo designs, things that are meant to be scaled and things like that. Whereas Photoshop is more for like raster-type images. Yeah, they both can do some things the other can do, but in general, Illustrator and Inkscape are meant to do vector stuff. As I mentioned before, the colors are used to separate the layers for power settings. So if your SVG file has a bunch of colors, it is not a color printer, but those colors can be used to segment out the layers and the power at which you want to run those layers.
So does that mean is it just line based, or can it be like a big blue square would cut out the whole square?
So the filling of that square would only show up in the raster section. So if you have a vector square, the vector square is going to have two settings. It's going to have the fill and the stroke. The stroke is the vector, the fill is the raster. So if you import an SVG image that has a fill in it, which is fine, that like this is based on a fill and it also has vector. So and you jump from the tab, there's a raster tab and a vector tab. You go to the vector tab, you only see the lines. You go to the raster tab, you only see the fill. So sometimes I'll do stuff where I've got some of the jobs back there I'll grab, but I'll do something where I'll do a raster first, and then I'll run the vector of the same image, so it creates an outline, and it can really make stuff kind of pop. So this is not finished really. Like I started to do the vector and it wasn't aligned well, so I stopped it. But essentially, like this, if I did the whole vector, it really pops out after that point. So in Inkscape, I'll just jump over to Inkscape. So let's say we just wanted to cut a square. So I've got a square. You generally want to work in inches, and because it makes it easier to convert the size. So this is 4 inches by 3 inches. This will fit. Object, fill, and stroke. This is where you get to your fill and stroke setting. So if I fill, then I can change the fill color. Okay. And then you want to make sure the opacity is all. You don't want to mess with opacity. Just leave everything at 100. It doesn't respect opacity. It's not going to do anything. So just make everything 100 opacity. Same with alpha. And then stroke. The main thing is you want to make sure that the stroke style is 0.001 inches. So you could have different colors to generate different power settings, all that kind of stuff. Either way, they all need to be 0.001 inches thick. Okay? So it doesn't have to have a fill. It doesn't have to have a stroke. If you're doing raster, it has to have a fill. If you're doing vector, it has to have a stroke. Well, I generally, no matter what, just leave both. And then you can choose to use one or the other or both once you import the file. And then I'll make the stroke red just so we can kind of see it. So it's going to be pretty thin. Yeah, it's like it's really thin, so you can barely even see it. But let me just take the fill out so you can. So a very, very thin red line you can see there. Okay, so I'll leave it like that just so we can see it. So, so this is a very simple job, obviously. If I wanted to add a second cut, let's create a second line, and then we're going to change the stroke paint of that to be yellow. So now we've got, oops, can't barely see it, but there it is, and it's also 001. Okay, so last thing before exporting this file, you want to make sure that the page size is less than the build volume of the printer, of the cutter. Okay, I'll say that again. The document size needs to be smaller than 20 by 12. Even if your image is small enough, but you left your document size large, when you import it, it's going to import the entire document. So when you check your perimeter steps, it's going to burn out the motor because it's going to try to, it's stupid. All computers are really stupid, obviously. We know this. It'll do whatever you tell them to do. So if you tell it it's 4 feet wide and you go to check the perimeter, so meaning like run along the border with the motor, it's going to just go to the right and bang against the right side, and the motor's going to keep spinning and burning until it thinks it's gone 4 feet. Does that make sense? So generally what I do is I make sure that in the document properties, I change the units to inches so that I can double check it, and then I just resize it to the drawing size. So basically it just shrinks the document size down to whatever the drawing is. Okay? So it's about 5 inches by 4 inches. That's great. Perfect. I will add some text because that's a common thing people want to do with this thing. So with a Z.
Is the font limited to what's on the computer back there?
Very good question.
You can vectorize
No.
it.
Yes, well, it depends. So what I would do if you have a font that's not standard is create the document and then export it as a raster and then re-vectorize it. So one way you can re-vectorize things is object to path basically is a function that lets you take a raster image and then it uses edge detection. So basically it'll pop up this little window.
Unless
Should.
it's a really clean raster image, though, that can make kind of
The edges.
Yeah, I mean, so I use this program called Super Vectorizer. I like it a lot. It's Mac only and it costs $30, but I use this stuff all the time. So, and I use really, really dense images that even Illustrator crashes on. So Super Vectorizer is good if you have problems with this. But there's also a website you can just search for like convert raster to vector, and there's like online websites where you can upload the file and you can download it right there. So, in general, if you want to take a photo and make it vectorized, just Google convert. There's 10 million ways to do it, and every way is fine. It just depends on the outcome you're getting. So
Inkscape will not do that.
Inkscape will. It's not working for me. So if you do trace bitmap, that's what it is. So object trace bitmap, and then basically you can use different settings to determine where it finds the edge. So you can either do brightness or edge detection or color, and then you can just test out the different ones to see the results that you get. It'll be really slow for really dense images, but that could take a bitmap. So if you want to do a photo and then make a vector image out of it, you'd import the photo as a bitmap, select it, and then run this on it, and then it will basically add a new layer. It'll keep the bitmap layer there, adds a new layer over it with the vector, at which point you can just delete the bitmap layer.
Yeah, but the font here is not a raster font.
The font here right now is a vectored font. So because I created it in Inkscape, if you made something in Photoshop or you just downloaded an image that had text in it, it's not going to have any knowledge about it. It just looks like a pixel, like everything else. So at that point, you need to vectorize it. You can always add new fonts to that machine back there too. And also, you can use your own machine to laser cut. You don't need to use the machine back there. So essentially, you could download the full spectrum software. Username and password's right here. It's not a limited license or anything. It's just to be able to download it. So essentially, if you're on the network, it's a network-connected laser cutter. You basically look at the IP address that's in the one already set up to find the IP address of the laser cutter, install the software yourself, and then put the IP address in. If you don't want to use that machine, but that machine works fine. So I will take the fill out of this and then add stroke, and then so it's already vectorized because it was made in Inkscape. So we'll make that a third layer, and we'll just make that green. And then I'm going to change.
As far as the different colors go, is there like a magenta has to be a set color value?
No, it will.
Close.
It will get any gradient difference. It will separate out as a layer. The only thing I would say is that just to be sure that you're setting the power setting for the right layer, make it different enough that you can visually say like, that is that layer, this is that layer. So.
Don't put a magenta next to a red.
Yes, exactly, right, and expect you to be able to remember which is which, because then you'll end up cutting where you want it to engrave or something. And in general, you might want to come up with a system to say, like, red always means cut for my files. It doesn't mean crap to that thing, but if you always remember, okay, red lines I cut, then when you see red, you change the power setting for that cut. So right now we've got a file with an outside yellow line, inside red line, and then we've got a green line with no fill. So I'm going to add a fill now. as well. So what we're going to do is we're going to test this piece out on the printer in the back. It's going to be a combination of vector and raster. So it's going to be vector, it's going to cut, vector engrave, raster engrave. Okay, does that make sense? So outside cut, this is just going to be an etching, and then etching on the outline of this, and then etching it's going to fill it as well. Okay?
How long would you expect that to take?
This is going to take about 5 minutes. So again, the main things you want to check before exporting the file: the stroke style 001 inches, the document size lower than 20 inches by 12 inches. If you're doing a raster image, it needs a lead in and lead out of 0.8 inches on each side. So you can't do a raster image that's a full 20 by 12. So the reason for that is basically because it's going across. It basically uses that first eighth of an, like not eighth of an inch, 0.8 inches to build up speed, so that it's going at a consistent speed across it, and then it slows down and then goes back. So if you want to do a full raster style image, just do like 18 inches by 12 inches, and that's 18.4 or whatever if you want to really max it out. Okay. So again, and then make sure the document size. The document size, seriously, like I've screwed that up a few times, and it's really painful. It's into that motor, and it's just a matter of time. If it happens enough times, it's going to burn out the belt, burn out the motor, something like that. And it's really easy to miss. So just double check the document preferences.
It'd be good to have like some pre-made templates that are just that size.
Yeah, and if someone makes one, it'd be nice to have like a standard file. Yeah, that's a good idea. Cool.
So what happens if you don't use .001?
It might not show up. It just won't show up, and when it imports it, I've seen it where it has, but I've also seen it where it hasn't. So like you'll have your file all set up, you'll import it, and then Inkscape will show it. You'll say, cool, print, and then Full Spectrum software sees the print, and then like half your stuff's not there, or
It's not something like the laser's going to do.
it's not going to like damage the laser. It's just not going to necessarily recognize those lines as being like the correct thickness or thinness.
So it's not actually a dimension that's respected. It's just
No, like if I put
either
it
is
to
a line or it
0.1 instead of 0.001, it's not going to make a thick line. It basically there's a tolerance setting in the advanced settings of it that tells it between which line thicknesses are you going to recognize as a valid vector size, and anything that's under or over those values is just going to drop out. So it's just for recognizing the thing. And then I'm
That
going.
just happens to be in the range.
0.001 is in the range, exactly. So, and I'm going to save as, and then you just select SVG. I don't know the difference between Inkscape SVG and plain SVG, but might as well just use Inkscape. Okay, so I'm going to put a USB drive somewhere. Again, if you wanted to just use your own computer, you can install Inkscape and install Full Spectrum on your own computer, connect it over to network. It's fine, but it's going to need to stay on the network and stay. The computer doesn't like upload the entire file to the laser cutter and then quit. It is sending messages to the laser cutter telling it what to do all the time. So if the network went down in the middle of a cut, it's just going to stop. Or it might go for like a couple minutes based on like whatever's buffered, but it's just not going to work. So again, if you want the username and password, it's in here. Okay, so before we go back there, because once we do get hands-on, from my experience in classes, it gets a little crazy. So are there any questions so far about Inkscape, safety, laser cutter, materials, something like that? Okay.
What's it do to leather?
Leather, it just burns. It burns. It just burns stuff. So
kind of look like a brand.
yeah, like a brand, exactly. You can get a really cool effect from it. So this is the manual. Like, are you guys familiar with the acronym RTFM? Read the effing manual. I highly recommend you read the effing manual. I skipped a lot of stuff. It goes over a lot of information. It's good to have. This presentation is available in this as well. So if you're curious about any of this stuff, it's all in here, and we leave this back there. just real quick, just some other stuff that's been done on this thing. I did this piece. It's a larger piece. It's all vector. This is just lines. And then this is a combination of raster and vector. So this is just vector. Laminate gives you really nice, clean, black lines for some reason. Wood is a little lighter. And I found, like, on that piece, I actually, if I pulled it out of the laser cutter and just, like, rubbed it or whatever, like, it would smear because it's char. Like, the brown is char. This black seems to be more of, like, a reaction. It's not, like, particles that are left over. So, like, I treated that with a, you can use an acrylic spray, or what I use is called a fixative. So people that do charcoal drawings and paintings use, it's just a fixative spray that kind of seals it. So if you want to do a wood job where you like the burn parts and you want to make sure they stay that way, use a fixative spray. You could also wash it or clean it afterwards, then you'll end up with a very, very faint indentation where the vector happened. Does that make sense? So, and then with this, I just cleaned afterwards. With this, I just wiped the whole thing down with alcohol, and these lines stayed. So it all depends on the material. If you're working with a new material, I would definitely say use a test piece, and I'll show you some tricks back there to kind of run a bunch of patterns with different speeds and powers on that test piece, so then you get a good idea before you ruin the expensive part, what it reacts with, what you need to treat it with afterwards, what you need to worry about, that sort of thing. And then this is a combination of raster and vector. So this raster gave me a nice, really thick black that hasn't been sealed, and it was just a happy accident that it gave me that kind of fill. So this was a very dense. So the DPI, there's DPI settings on the raster image. Do you guys know what DPI is? Dots per inch, I think it is. So essentially, it's if you're doing vector, it does not matter. If you're doing raster, the DPI settings matter a lot, but mostly for the amount of time it's going to take. So the default's 500. If you just pull up the software, it's 500 by 500, right? This was done at 250 by 250, so it's lower, worse resolution. So this piece, 250 by 250, each pass would take a half hour to go through this. Can anyone guess what it would be for 500 by 500?
2 hours.
Close. It would be an hour, just doubles every time. I thought the same thing, but it doubles. So an hour per pass. So this was 8 passes, so instead of 4 hours, it would be 8 hours. And then 1,000 by 1,000 would be double that. It would be 16 hours for this piece, right? So you want to do it based on the job you're doing. Does it require that level of detail? And then also, what to note is that it's not just going to be more detail, it's going to actually burn it more because it's hitting, let's say, within this inch on one line I hit 250 dots in the inch, right? So, because it's a pulse, right? So if I do 1,000 by 1,000 with the same exact power settings, it's not only going to take 4 times as long, it's going to burn it 4 times as long. The laser's spending 4 times as long touching the surface. Does that make sense? So you actually need to, if you want to change the DPI settings, I would recommend by default doing 250. Unless you start to see a need to do more, and then when you bump it up, play with the power setting too. Use another test piece. Don't expect it to look the same, but just more resolution. It's going to burn it a lot more too. Yep. Cool. I've got a few more pieces I'll show you after I'll pull out some pieces I made.
So
All right.
you did this big one by taking off the bottom.
Yes, so this was done by taking off the bottom and doing it in sections. Don't do that unless I walk you through it. And the main reason is it makes it really easy to misalign the laser. If you're moving the thing around, jostling it, it's going to get misaligned, right? So it's difficult to realign. It's not part of this 101 class. If there's interest, I would love to teach how to do the 3D engraving, how to align the laser cutter as an advanced class. If you have an interest in doing a larger piece, just let me know and we can work together on it. I'm not saying you can't do it. I'm just saying if you're in here by yourself, don't take the bottom off the thing. Just work with me on how to do it. There's a few tricks I figured out in how to check the next, because the alignment for the next section is the toughest part. Because basically, if you need to realign exactly on where it is, you have to basically create these test marks in the 4 corners and move it and realign it with those test marks. But even so, I've still screwed it up a few times doing larger pieces. So, I got a piece for outside. I'll show you where I screwed up. So I did this one too. And you can probably guess where the edge is. Yeah. So even with the realignment, it screwed it up. And sometimes what happens is, and I don't know why it always happens, but sometimes if you have a raster and a vector, it should, like if you run the raster and then you run the vector after, the vector should realign with the raster. But with vector images, it's going to kind of shrink it down a little bit. So like, it's always good to create, like, let's say this yellow line that I made. Even if I didn't want to cut along the border, you probably want to make a border to basically make sure that it doesn't over shrink your thing. So essentially I might like make that yellow border and then basically set the power and speed to 0 on the yellow line just to make sure that both modes are using the same reference point. Does that make sense? So if this yellow line did not have vectors, just filled, when I go to the vector tab, it's going to actually start here instead of here, because this doesn't mean anything to the vector. So basically, I create a fake border even if I'm not going to use it to cut anything. Yeah, so let's go cut this thing. And if we need to, I can do it twice.
Take a shell, jump across the canvas, jump with the shell, throw it up, catch it, jump, throw it up, catch it, and then keep you floating. That's why I like this thing with this. Looks like